We have a passive track. All our electromagnetics is in the pod. You have railways, you have a flight. So basically we are trying to combine both of them. So our estimated speed is around 1200 kilometers per hour, Chennai to Bangalore in 20 minutes.
Now, in your track, in the middle, there's this thing we call T section.
We evolved the Hyperloop technology. So in India, we are the pioneering team.
Hi, welcome to Best Place to Build Student Edition. I'm Vidhi, a fifth year engineering design student at IIT Madras. We are here with Avishkar Hyperloop today, the team pioneering the future of India's Hyperloop research. So, I'm here today because I have numerous questions. What is the Hyperloop? How does it work? How is the student team pulling this off? And is this something that belongs to science fiction, or will it one day be commercially scalable? I'm here with Praveen today to answer all of these questions.
Hi.
Hi Praveen, nice to meet you.
Yeah, hello Vidhi.
So, you'd be a great person to tell us what is Avishkar.
So Avishkar Hyperloop is a competition team in C5 where we not only concentrate on the competition, rather we are a research team plus a competition team. Basically, we participate in competitions in Europe, but the start of our Avishkar tenure was like in 2017. Elon Musk coined this term of Hyperloop and started a competition in USA. It is called SpaceX Hyperloop competition. So we went there for the first time, but we came 42nd and we didn't get selected. But the second year we finished in top 10. So that's how this team was started by a bunch of PhD students in INSTI, and then slowly it shifted to BTech, and now we are in our 9th generation of Hyperloop.
That's a very inspiring story.
Yeah.
So to start off with, what is the Hyperloop technology exactly? I have heard that yes, this is the brainchild of Elon Musk, possibly the fifth mode of transport.
Exactly.
But in simple terms, what is a Hyperloop exactly?
You have railways, you have a flight. So basically we are trying to combine both of them. The speed of airplanes with the cost and running efficiency of a train. So what basically this does is, if you take a train, what are the engineering inefficiency that you have? The friction and the air drag, it keeps fighting against that. So major power is being lost over there. What Hyperloop does it alternatively is that it levitates over the track. It does not touch the track, as well as it runs on a semi vacuum tube. So the air drag is also as minimal as possible. So in that way, we have very low power consumption while running the pod.
How fast do you think this can run?
So our estimated speed is around 1200 kilometers per hour, but that doesn't give any picture to you. Rather, I would say it as can go from here Chennai to Bangalore in 20 minutes.
That would be amazing,
Yeah.
truly. And around what cost?
I mean, so this right now we are doing the proof of concept of the Hyperloop technology. So we do a small scale model. So that costs pretty less, but the actual model will be the scaled up version of it. So whatever we are trying to make, that cost will be multiplied into the scaling factor.
Understood. And in Avishkar, are you building just the pod that will be going through this, or the track as well?
Yeah. So in order to differentiate it from the railways and the existing technology like maglev and stuff, innovation also goes in the infrastructure. If you think about it, the pod is just 1 kilometer long or something, where the track is thousands of kilometers long. If let's say even you reduce 1% of cost in the track, that will enhance your economics by a lot. So we try to make our track as passive as possible, as least material consuming as possible, with the structural integrity that we are expecting it to have. And the tube also, we have a patent for it where we reduce the thickness by 47%. So infrastructure is indeed a very important thing that we also work upon, not just the pod.
All right, that's very impressive, and it makes sense to be working on both the technologies together.
Exactly.
You mentioned maglev,
Yeah.
which is something I think people often confuse with the Hyperloop
Yeah.
technology itself. Could you tell us the difference between the two?
Every time I pitch to someone or say someone, everyone asks, how is it different from a maglev train? So what exactly, and you know that maglev is not economically a successful project. That is because they had magnetics on their track. They had copper coils on the track and they have to power it. Lays over kilometers and kilometers, the cost just multiplies by the amount of the track. Rather, we have a passive track. All our electromagnetics is in the pod. So all the motors, all the levitation systems, it's in the pod, where a track is just a ferromagnetic material and an aluminum T-section for the propulsion. So you know air drag is directly proportional to the speed at which you go. So they consume most of the energy fighting the air drag rather than increasing the speed of it. where we don't have to do that. So our energy consumption is also less, we can reach much higher speeds. So that's how Hyperloop is differentiated from maglev.
Also, you had mentioned that the first competition that you started to go for as part of Elon Musk's
Yeah.
SpaceX competitions, that was discontinued post
Yeah.
2 years. So, which competitions do you guys attend these days?
So right now we attend 2 competitions. One is European Hyperloop Week, where a bunch of European colleges in a round robin method organize that competition every year over a week in July. And we go there, we present our pod, and we get judged based on that. And second competition, which origin from Avishkar Hyperloop, the sister team, Global Hyperloop competition, which we initiated in India to spread the Hyperloop culture in India, so that other teams from other college starts working on that, so that we have competitors to actually work together.
Right, that sounds amazing. And how do you judge between, different Hyperloop technologies? On what metrics are you guys judged? Is it the speed or the track length that you are able to cover, or the power consumption?
Yeah, basically 3 things that they concentrate on. One is the scalability factor. You can make a pod run very fast and very aggressively, but if your energy consumption goes very high, again it disproves the point. Cost also of the track also should not scale up so much that it reduces the advantage that you get by the power reduction. Second thing is safety. Like how safe is your pod, how safe is your track system, how safe is your entire vacuum system if you are making one. So that is the second consideration. Third is the technology in itself. So that part is slightly cliche because it's a developing technology. It's not like an existing, like say a drone competition where they know you go this much height, this much speed, you come back. It's a developing technology where they dynamically change. Sometimes they see how fast your thing run or how stably it levitates and how energy efficient it is. How well have you thought about the cabin design if per se like that. So there are multiple metrics where we get evaluated and it keeps changing year by year.
Got it. Okay. And currently, like these pods,
Mhm.
they do not have any passengers that they're designed for yet. Is
Yeah.
that something that you guys are building towards?
Yeah. For now, this pod is freight capable, like for freight transportations. Again, passenger cabin is one of the things which we are working on right now. Even the Global Hyperloop competition has a cabin mock-up design challenge. Our cabin system is different from, let's say, a train or a metro or airplane, where here even the oxygen exchange has to be done inside the pod because it's in a vacuum. You have to maintain the oxygen levels, remove the carbon dioxide, keep the temperature stable. All those things has to be done. So that part of the research is also going on in our team.
Wow. So a lot of factors to consider together apart from the tech itself. That's amazing. And how has Avishkar Hyperloop been performing against its global peers?
Say in India, we are the first team which we evolved the Hyperloop technology. So in India, we are the pioneering team. But in Europe, there are teams from the European colleges where in last competition, if let's say we got first in our socio-economic research and second in our full-scale technical research, which proves that we are a strong research team. And we came fourth overall in the engineering design as well as the overall competition. We came fourth. In Asia also, we came the first. All the first 3 teams are European teams.
That's quite remarkable. It's
Yeah.
amazing that this team from IIT Madras is doing so well. But outside of research labs and these student competitions, there are a lot of skeptics about the Hyperloop
Correct.
as a mode of transport. What is your take on this?
Before the Wright brothers, no one said they can fly. And it did happen after so many years. At the start, they did some pedaling stuff and then it flied. Over the year, you can see how much scale of the technology has developed. It's still in its baby phase, so we should nurture it rather than discouraging it. So that's how I feel about it. So the more the time and effort and the hope that you give on the technology, the better the technology will scale up.
That is true. As the technology matures and with mass production and sister technologies developing alongside, cost does go down. But currently, most of the skeptics find the infrastructure laying costs very high, since you need to lay out thousands of kilometers of a vacuum tube and a track and have the pod built in. And even while it might become technologically feasible at one point, they're afraid that the logistics wouldn't add up.
Yeah, most of the cost goes in the infrastructure and maintaining the vacuum part of it. When it starts moving, actually the amount of energy it consumes is really, really less. So the amount of power that you provide for it to move is very less. So again, power is money here in this generation. So that reduces the cost of landing so much that the initial infrastructure cost, if the technology runs for let's say 10-20 years, will be brought back and will break even at that point.
Right. So the running costs are so low that eventually you hope that it will be making up for the fixed capital that was invested.
Exactly.
This could be a future technology and not just science fiction. That's great to know. And one doubt I had, since this tube is running in vacuum, any wasted energy or any dissipated energy in the form of heat, where would that energy go since there is no air to transmit it across?
And that's a deep question now. That is a genuine concern. So where it's levitating, it's not touching anything, and it's also in vacuum, so it cannot conventionally radiate it. So we have a thermal subsystem separately to handle the power losses that you say about. So we take it and reserve it in a phase change material, and we also researching upon low vapor pressure boiling. So basically we are trying to use our disadvantage like vacuum and stuff to actually gain advantages out of it. So that is what we are trying to do as a team to make it more scalable.
Quite interesting. So how many modules do you have in Avishkar?
So we have around 7 modules. So electrical, then levitation, propulsion, infrastructure, thermal, mechanical, and GUI.
Oh, okay. What does GUI do?
So basically, it's not that simple as you control a train. Basically, if you have a train system running in a city, so you'll have a base station where you have like an heads up of which is where, how, what speed it is going, what is the state of the pod, is there any error that is showing up. So basically, we have a subsystem which does the similar thing. We take all the data from the pod and represent it in a graphical user interface so that a layman also can operate the technology. It's a again, it's a pilotless technology.
Great. And this year, what improvements are you working on for July?
So for this CHW competition, one thing is on research topic we are working on making the tube out of concrete rather than steel. That would surprise you, but if you mix concrete in a certain way, that also has low permeability capability where it does not allow air to seep into that. But the advantage that you get is cement is all over the world. Like it's the first most abundant thing that you use every building. So that brings down the cost again so much. So Avishkar is a cost concern team. In India is a cost concern country. So Avishkar turned out to be a cost concern scalable team. So that is one thing we are working on. And as I said, the thermal team is working on using the vacuum environment outside the pod to actually cool the pod inside. So that is one thing. Then we are doing a cabin mock-up where we are trying to have a seat kind of thing and oxygen supply and the temperature controlled, all those things.
Many new developments and very research intensive.
Exactly.
Like as compared to other teams I've seen here, there sounds to be a lot of cutting edge research that you guys are bringing about.
Exactly. So we as a team, yeah, don't buy modules out the shelf and connect them, and we don't work on the what do you say, performance aspect of it. We work on the technology aspect of it. So most of the time you won't find people over here because they would be either been lab or doing some research or contacting some professors. In that way, we are extremely research intensive.
That's amazing. You're maxing out on the whole IITM ecosystem and making
exactly.
use of each and every part. Praveen has explained to us what the Hyperloop technology is, what Avishkar Hyperloop is working on. To delve into the details of how the pod actually works, how they're making it work, we're here with Mohammed right now. Hi, Mohammed. Nice
Hi.
to meet you. So, how does this pod actually work? Like, it's a floating pod in vacuum going at high speeds.
Yes.
That's about all that I know about.
We have various subsystem working on different things. So in the pod, mainly we have your levitation module and then your propulsion module for movement. You have two levitation. You can divide it into two parts: your vertical and your horizontal or lateral. So for the vertical, we use a hybrid electromagnetic system where you have a permanent magnet along with an electromagnetic system. And your electromagnetic system takes care of achieving your required air gap. But once it is achieved, your permanent magnet is has the capability to lift the pod by itself. So we use this hybrid mechanism to conserve on energy. For lateral, it's a simple electromagnetic system itself, just to guide it along the track so that it doesn't get. For propulsion, we have a linear induction motor. How it works is it generates these alternating currents onto the track. Now, in your track, in the middle, there's this thing we call T section, which is just a aluminum plate going along the track. And there are coils on the pod that surrounds this. It produces these alternating currents, which will induce a force which propels it forward.
Okay, understood. So, two major components. We have the levitation, and then once it's up, you have the propulsion, which
Yes.
takes care of it. And in levitation, you mentioned that first we have the electromagnets to create the liftoff,
Yes.
And to maintain it, hold it there, you have the permanent magnets to reduce energy consumption.
Yeah.
And for propulsion, there I'm still a little bit confused how it entirely works, because in any other mode of transportation, you have a motor or something which spins and it exerts force on the ground, and that is what creates the pusher.
Yes.
But here, since it's a contactless mode, how is that force being generated?
So it works on the principle of Lenz's law. So in school or something, we might have learned that when you move a metal piece through a magnetic field, it induces a restrictive opposing force. Similarly, if you keep it stationary and change the electromagnetic field, you can achieve the same result.
Alright, so this way you have the active pod, which is controlling the propulsion, changing the magnetic field.
Yes.
And the track is a passive system, and it's just reacting and experiencing a force, and the opposing force is experienced on the pod, causing the propulsion forward.
Yes. One issue with this is the energy resource of your LIM is completely dependent on your pod. We don't have that much space to keep your batteries. Like that'll be too much of a requirement for your energy. So what we do is initially we put this thing called a booster motor. So that is on the track and powered by the grid. That will accelerate the pod to a very high velocity, so that then your LIM can just either maintain that speed or just have a slight increase. And since it's already in vacuum with no friction, there's no more energy requirement at all.
Okay, that makes a lot of sense. For the initial first powerful force, you're taking that off the grid and isolating it from the pod. You have
Yes.
that on the first section of the tracks. And force that, just to maintain the speed, you have your pod having the axis
Yeah.
control. Understood. What other subsystems are part of this? Like Praveen had mentioned, there were 7 modules.
Yes. So we have our thermal, electrical, levitation, propulsion, mechanical, business, and I guess socio-economic. Levitation and propulsion, as discussed, is what they do. Mechanical, we work on the chassis, the holders, FPOCs. FPOCs basically to make sure your pod doesn't hit the track or hit the magnets. We also have the passenger design, as Praveen said. And thermal, they research on ways to cool the batteries, ways to cool the components, ways to cool the lean induction motor as well. And we have infrastructure also. So infrastructure, what they work is on the tube and the track. So on the track side, they research about docking, how when the pod comes, how will you receive passengers, how will you put the passengers, since it's a vacuum system, you need some sort of interface. We also have the business, and under the business we also have the socio-economical. So what business take care of is finances, and the socio-economical subsystem, they research on basically societal impacts of a hyperloop. Once it comes, how will society look, what sort of changes will there be, things like that they research on. So every year they take some topic and research extensively on.
So this year, what are you guys researching on?
The current topic is about how once Hyperloop is established, how it will affect job sectors.
That's quite interesting. And looping back in on the infrastructure aspect,
Yeah.
has there been any breakaway or difference that you guys have made on the tube infrastructure? We've talked a lot about the pod itself, but the track and the tube.
So one power thing for us is that we have been able to reduce the thickness of the pod to 6 mm, and based on that design, we even had it we had a design for which got constructed in Tayyur, the extended campus of IIT Madras, a 422-meter tube. So generally, pods tubes are thicker, maybe 10 mm, 20 mm or something, but we have been able to design a tube of just 6 mm. And that, since your tube is the major infrastructural cost, that really reduces the cost.
Understood. And how has your experience in the competitions been so far? Which country have you been to for the competition?
Last year we went to Netherlands, and it's a place called Veendam, where they have a European Hyperloop Center, EHC, which is where the competition was conducted. It was quite a learning experience. We saw a lot of other teams, and we were able to really see what they are working on. And it's crazy what other teams also do.
That's great to know. And are they collaborative and ready to share the knowledge that they have?
Yes. So when we go there, whenever you just go to some team and ask what they're working on, they're always helpful. Even if they're busy, they take their time out of and just explain us how their pod works, what sort of improvements they're made. And it was quite a learning experience. Like there's a lot of exchange going on, and whatever doubts we had, we were able to talk with them, and whatever doubts they had, they were able to talk with us.
Was the competition experience as smooth sailing as you're making it sound? Because I've heard about a lot of ups and downs generally happening at these competitions.
Not really, but yeah, I will have Bhupal and explain more about that.
So we actually called you here since your teammate told us that there was some very disastrous or scary experience during the competition time, and you'd be the best person to talk about it.
For our recent competition that we went, ESW 2025, we had to ship our pod long back, but since we couldn't manufacture and do the test run of our pod, we were behind the schedule for 3 or 4 days. While the team is packing every stuff for the competition, we had to go outside and then test the pod simultaneously. So if you want some spanner, once you will have it, and then the next time it will be packed up. So that is how we made it to the competition.
So as a team lead right now, keeping the entire schedule, the team on schedule, and managing the team would be very difficult. So have you implemented any techniques on how you get the team to be running on schedule and not have a repeat of what happened the previous year?
I can give you a quick example for that. What the last year team head did was that, let's say we have a submission for December 30th. What the team head actually would do is, he would announce the submission date as December 25th, so that the team can complete everything on 25th and improve it. But you guess it, it won't happen. As usual, we submitted on the last minute, December 30th at 12 p.m.
Yeah, being a team head must be quite challenging. Even for a team of 5 or 6 people, there are so many inconsistencies that are there. And Avishkar Hyperloop being one of the bigger teams with 60 to 70 members, I can imagine that's quite challenging. Yet you guys are doing such amazing work as a student team itself with cutting edge research. It's been great talking to you today. Thank you so much for your time.
Thank you.
So in today's episode, we looked over Avishkar Hyperloop, the progress that they've been making innovations not just in the pod and the propulsion technology, but even in the track and tube infrastructure. Maybe we are not too far away from the Hyperloop becoming a reality. Maybe someday we'll be able to go from Bangalore to Chennai in the span of 20 minutes. If you like this content, then do like, share, and subscribe.